Good morning, dear students. Today we will learn about complex numbers. In previous class, we learned about complex numbers formulas and problems. Complex numbers, and we discussed about De Movers Theorem. Objectives. On completion of the period, you would be able to solve the problems using De Movers Theorem. Recap. We know that De Movers Theorem. If n is an integer, positive or negative, then cos theta plus I sin theta whole power n equals to cos n theta plus I sin n theta. A fraction positive or negative, then one of the values of cos theta plus I sin theta whole power n is cos n theta plus I sin n theta. Problem 1 or question 1. X plus 1 by x equals to 2 cos theta or cos alpha. Then x power n. Then prove that x power n plus 1 by x power n equals to 2 cos n alpha, and x power n minus 1 by x power n equals to 2i sin alpha. I think it is sin n alpha. N is not printed here. So I am reading once again. The question is, if x plus 1 by x equals to 2 cos alpha, then prove that x power n plus 1 by x power n equals to 2 cos n alpha, and x power n minus 1 by x power n equals to 2i sin n alpha. So some condition is given and asking the proof. So see the solution. Write first given statement or condition is x plus 1 by x equals to 2 cos alpha, and in the second step we did LCM. So x is the LCM. Then in the numerator we can write x square plus 1 equals to 2 cos alpha. Then the denominator x is, if we send to right side, it is multiply with 2 cos alpha. So, and if that 2x cos alpha brings to the left side, it becomes negative, and the right side is, we can write 0. So the next step is x square minus 2x cos alpha plus 1 equals to 0. And here we are finding the x by using the formula minus b plus or minus under root of b square minus 4ac by 2a. So a means 1 and b means minus 2 cos alpha, and c means 1. So after substitution we get like this: x equals to 2 cos alpha plus or minus under root 4 cos square alpha minus 4 by 2. Next, that equals to 2 cos alpha plus or minus 2 into under root of minus sine square alpha whole divided by 2, and that equals to cos alpha plus or minus I sine alpha, because minus sine square alpha means we can write under root of minus 1 into under root of sine square alpha. Under root of minus 1 means it is I, and under root of sine square alpha, so square root get cancelled, so we can write sine alpha. So if we took the 2 common from the numerator, then numerator and denominator get cancelled, because in the denominator also we have 2. So the next step is cos alpha plus or minus I sine alpha. Consider x equals to cos alpha plus I sine alpha. So we are taking positive. Then x power n equals to, we can write cos alpha plus I sine alpha whole power n. Then that equals to, from Movers theorem, we can write cos n alpha plus I sine n alpha. That is considered as equation 1. Next, 1 by x power n equals to cos n alpha minus I sine n alpha. Consider it equation number 2. Therefore, equation 1 plus 2 gives x power n plus 1 by x power n equals to 2 into cos n alpha. And equation 1 minus 2 gives x power n minus 1 by x power n equals to 2i sine n alpha. Question number 2. Prove that one plus cos theta. So here printing is mistake, but we can hope that is a plus I sine theta whole power n by 1 plus cos theta minus I sine theta whole power n equals to cos theta plus cos n theta plus I sine n theta. Once again I am repeating the question, that is number 2, question number 2 or problem 2. Prove that 1 plus cos theta plus I sine theta whole power n by 1 plus cos theta minus I sine theta whole power n equals to cos n theta plus I sine n theta. Next, see the solution. Here we took LHS, that is 1 plus cos theta plus I sine theta whole power n by 1 plus cos theta minus I sine theta whole power n. That equals to 1 plus cos theta can be written as 1 as it is. Cos theta can be written as 2 cos square theta by 2 minus 1. This is from cos 2 theta formula. Cos 2 theta equals to 2 cos square theta minus 1. Here 2 theta is not, only theta is there. So cos theta, then we can write 2 cos square theta by 2 minus 1 plus I into sin theta, also we can write 2 sin theta by 2 into cos theta by 2. This is also from sin 2 theta. Sin 2 theta we can write 2 sin theta cos theta. And from that, in place of 2 theta we have theta. So in the right side part is also changed. Therefore sin theta can be written as 2 sin theta by 2 into cos theta by 2. So whole power n as it is. Next, in the denominator also we are taking, in place of cos theta, 2 cos square theta by 2 minus 1. So 1 plus 2 cos square theta by 2 minus 1 minus I into, again sin theta also we are replacing with 2 sin theta by 2 into cos theta by 2 whole power n. That means in the numerator and denominator we are both applying the formulas. That equals to plus 1 minus 1 get cancelled. 2 cos square theta by 2 plus I into 2 sin theta by 2 cos theta by 2 whole power n by 2 cos square theta by 2 minus I into 2 sin theta by 2 into cos theta by 2 whole power n. That equals to 2 power n into cos power n theta by 2. We are taking common here. So in the bracket we can write cos theta by 2 plus I sin theta by 2 whole power n. So here see that in the numerator cos square is there. So one cos is took common along with power, and 2 also along with power. Then that's why here we write as a common, that is 2 power n into cos power n theta by 2, and in bracket we are writing as it is cos theta by 2 plus I sin theta by 2 whole power n. So here we are taken 2 cos theta by 2 common, and the power is also we are applied because whole power n, and in the denominator also same, we are taking 2 cos theta by 2, but already power whole is n. So then it is, if we took completely outside means we can write 2 power n into cos power n theta by 2 of remaining, after taking common in the remaining bracket, remaining terms in the bracket is cos theta by 2 minus I sin theta by 2 whole power n. So numerator and denominator, the common part is get cancelled. Next, in the bracketed terms we can express it in the exponential form. So exponential form is we can write, suppose if cos theta plus I sin theta whole power n, that means e power I theta whole power n. Similarly here we have, in place of theta theta by 2. So we can write as exponential form is e power I theta by 2 whole power n. The power n is as it is, and in the denominator e power minus I theta by 2 whole power n, that equals to e power I into n theta by 2 by e power minus I n theta by 2. Power of power means they will be producted or multiplied. That equals to fraction. In the fraction, bases are same, means the powers should be subtracted. So one base is written and the powers should be subtracted. So e power I n theta by 2, minus of minus means plus. Here plus is not printed, so we have to put plus symbol between them. So sorry, here what he did means the fraction is taken to the upside, that means in the numerator. So the power minus becomes positive. So e power I n theta by 2 into e power I n theta by 2. Then he added the powers with the rule of a power m into a power n means a power m plus n. So bases are same means, and if the product is in between them means we can write one base and we add the powers. Same here, after adding the powers we get e power I n theta, because theta by 2 plus theta by 2 means theta. So, or we can say half of means 1. So you can take like anyway, then that equals to cos n theta plus I sin n theta. So from exponential we are again expanded. So this is the RHS. Hence we proved. Next question, that is third, problem 3. If z equals to cos theta plus I sin theta, then show that z power 3 plus 1 by z power 3 equals to 2 cos 3 theta, and z power 3 minus 1 by z power 3 equals to 2i sin 3 theta. Solution: z power 3 equals to cos theta plus I sin theta whole power 3, that equals to cos 3 theta plus I sin 3 theta from Movers Theorem. Next, that is consider equation as a 1, and next step, one by z power 3 equals to cos theta plus I sin theta whole power minus 3. In the denominator we have power 3. If it comes to, or we bring the numerator, then the power becomes negative. So then if you apply the demovers statement, then that equals to, we can write cos 3 theta minus I sin 3 theta. Consider it as a equation 2. Now adding 1 plus 2 gives left side terms should be added one side and right side terms should be added right side. So z cube plus 1 by z cube equals to, the right side positive and negative terms get cancelled. That is I sin 3 theta minus I sin 3 theta get cancelled. And cos 3 theta plus cos 3 theta means 2 cos 3 theta. Next, subtracting the equations. That is 1 minus 2 gives z power 3 minus 1 by z power 3. That equals to, now here subtracting means cos 3 theta get cancelled, and I sin 3 theta minus of minus means plus I sin 3 theta. So 2I sin 3 theta is there. So this is the how we showed. Very simple. To show, first we have to observe what is in the LHS, how the terms are there. If we know that terms, we can easily get RHS. Here directly terms are not given, but that term is given in a condition. From that condition we are getting the left side terms or left side part of the terms. Then we can directly showing the what he is asked. See next question. Problem number 4. If means condition, capital X equals to cos alpha plus I sin alpha, y equals to cos beta plus I sin beta, then prove that x square y cube plus 1 by x square y cube equals to 2 into cos of 2 alpha plus 3 beta. See the solution. First we took given condition is x equals to cos alpha plus I sin alpha, and it is expressed as a e power I alpha. And then x square equals to e power I into 2 alpha, because squaring on both sides. So powers of the powers means the powers are product are multiplied. So we already know a power m whole power n equals to a power m into n or mn. Similarly here we wrote x square equals to e power I into 2 alpha, and similarly we can write y power 3 equals to e power I into 3 beta, because y is also expressed as a cos beta plus I sin beta. The difference is alpha is replaced with beta. That is the difference only to x and y. So we can easily say or easily write y power 3 equals to e power I into 3 into beta. Next, x square into y power 3. Now we are taking LHS, that is x square into y power 3 plus 1 by x square into y power 3 equals to, here we are substituting the values of x square and y cube. So we can write e power I 2 alpha into e power I 3 beta plus 1 by e power I 2 alpha into e power I 3 beta, and that equals to, we can write e power I of 2 alpha plus 3 beta plus the denominator goes to upside, the power is negative, so e power minus I of 2 alpha plus 3 beta. Then from exponential we are writing polar form or de Movers form. So that is cos of 2 alpha plus 3 beta plus I sin of 2 alpha plus 3 beta, and plus the second term also, here we are writing the de Movers theorem or polar form. Sorry, here we cannot say polar form because polar is containing r into e power cos of, so here r is not there, so we say de Movers. So or we are expanding the form from exponential to cos and sine terms, or we can say de Movers. So in any way, no problem. So plus second term is expressed as a cos of 2 alpha plus 3 beta minus I sin of 2 alpha plus 3 beta. Then that equals to, positive and negative terms will be terminated. The remaining is cos of means 2 into cos of 2 alpha plus 3 beta. So this is the proof. So if we observe the question is asking prove that, but in the left side terms directly we know the values. So first we did each part of the left side taken and find out. Then we took complete LHS, and then from that we are showing RHS. So based on condition we will find the parts of the LHS. So summary. In this session you have learned to solve problems using de Movers theorem. So here one thing we have to remember, e power I theta means cos theta plus I sin theta, and e power I n theta means cos n theta plus I sin n theta, because de Movers is power n means de Movers is applied. Simple. So here quiz is given. Let us see what is the question. quiz. First one, additive inverse of x plus iy is. I think it is very easy question, very simple question. So answer is A. That is minus x minus iy. So additive inverse is very simple. Just multiply with opposite sign. Here x plus iy is containing positive, and if you multiply with opposite sign means negative, that is minus. So minus of x minus x and minus into plus y minus y, so minus iy. Okay, next so answer is here A. And next, polar form of x plus iy is. So polar form and modulus amplitude form is the same. So A, B, C, three options are given. So I think you can find easily. So answer is C, that is R of cos theta plus I sin theta. So polar form is we can say modulus amplitude form. Next question, the exponential form of x plus iy is. Here four options are given. So exponential form of x plus iy is r into e power I theta. R into e power I theta. Assignment. So some questions are here giving as assignment. You should do these problems, and if you have any doubts while doing the problem, if you are not getting the required solution or answer or proof, you can ask me. I will clarify your doubts. You can mail me, you can message me. I will tell you. So you are doing assignment means you are trying the question, you are trying the answer, you are using the formulas, you are applying the properties. So all are involved. So you should do assignment. First question is express the following in the modulus amplitude form. So number 1, minus 1 minus I, and number 2, minus root 7 plus I into root 21. Second question. See, here question is not or any letters not visible clear, then you can see in a textbook also. Assignment problems are you can see in textbook exercise problems or example problems. Next, second question. Find the additive and multiplicative inverse of the following complex numbers. First one is 9 by 2 plus I into root 5. Second one, 2 plus I into minus 4 plus 6I. Third question, prove that cos 3 theta plus I sin 3 theta whole power 4. Here bracket is not printed, we should keep the bracket, into cos 4 theta minus I sin 4 theta whole power 5 whole divided by cos 4 theta plus I sin 4 theta whole power 3 into cos 5 theta plus I sin 5 theta whole power minus 4 equals to 1, and in the denominator also the bracket is missed, so we should keep the bracket. Next, number 4. If A equals to cos alpha plus I sin alpha and B equals to cos beta plus I sin beta, then prove that A square minus B square by 2AB equals to I into sin of alpha minus beta. Frequently asked questions. This means these questions are asked in the examination previously. So if you are doing these questions means you can do the question paper in the final or end exam, and you have idea how the questions are coming, whether it is easy or hard or medium. See here, first one. Find the real and imaginary parts of the following. 4 plus 2i by 1 minus 2i. Second question. Express the following in the modulus amplitude form. Root 3 plus I. Third one. If z equals to cos theta plus I sin theta, then show that z power 3 plus 1 by z power 3 equals to 2 into cos 3 theta, and z power 3 minus 1 by z power 3 equals to 2 into I sin 3 theta. So these are the questions how is asked, how was asked in the previous exams. So after completion of these questions, that means assignment and frequently asked questions, then you do the exercise problems from the textbook. In exercise also we have problems. Some questions, some problems here we are covered in the class, I mean in PPT or video classes. So based on this, you can easily do the or solve the questions or sums or problems from the exercise. So first write in the rough notes and then maintain neatly in the fair notes and serial wise, that means order wise. First question after write second, second after third. That means if any question is you are not done, means it is easily you can recognize, because in the order, suppose you are not writing 4 means, that means the fourth one is, if you are not practiced or not tried, or on fourth question you have a doubt. So order is must. So you can think for how to do the fourth question, and if you don't know, then you can ask me or you can ask your friends, classmates. Then you write, but without 4 you don't write 5. You can do in the rough notes, but not write in the fair notes, because don't jump the order. You are writing in the fair notes means, in the fair notes it contains all the exercise problems. Suppose you said, sir, my second chapter is completed, or you said, sir, I completed the second chapter, or I have completed the second chapter, means in the second chapter, if exercise contains 10 questions, that 10 questions should be in the fair notes and orderly. Why I am saying order means, when you are after few days, when you search for in the second chapter third question, if you are writing order means it is easily we can search or find. Otherwise it is very difficult and no use to say it is a fair notes. Fair notes means write neatly, and if you know, then only write. If you clear your doubts, then only you write, and order wise also write. It is useful to you, and if I observe, it is easy to scrutiny for me also, because in order I will go. If there is a missing means, I can easily find out, and you can complete that which is missing. So first thing, if you are writing orderly means indirectly you know which is missing, because it is missing means you are don't you are not done in the rough notes. So you are writing in the rough notes means, and you are doing fair means there is no chance to miss. In the rough notes it may miss sometimes. First we do easy problems, then later we do some different types of the problems. So but when come to the fair notes, order is important. So based on the order you are writing means, you think, is it completed or solved in the rough notes or not. And one more thing is, when opening the video, first open the PPT in any device, because every video is containing or relating or class on the PPT. Sometimes in video the letters may be not clear or not visible properly. To overcome this problem, if you open the PPT in another device, or if you have only one device, first open the PPT and take the notes, then listen the video. My each video is containing PPT also, so only PPT is also available. So those are want, I can share you, I can send you the PPT. It is very less consumes the data compared to video. In video, if screen clarity is good, no problem. If screen clarity is not good, then if you are seeing PPT means, so then the screen clarity is no issue for you. So first, before going to do the problems, first read the properties and formulas, then observe the example problems in a textbook also, then you do the exercise problems. So complete each and every problem, and I will check your fair notes. After completion, you tell me, sir, my notes is fair notes is completed on this chapter or on this so and so unit. Then I will see your notes. And if you're completing the fair notes means you will the chance to get good marks. And sometimes it's affect on internal marks also. So you will able to do the problems if you are completing the fair notes means, because it is practiced twice. First you have to write in the rough notes, then fair notes. So in any angle it is good for you, so don't pending. And I know you can write. And this complex number chapter is very easy. Most of the questions are proved, that means question is there, answer is also there. So, and formulas are also few formulas, properties very few. So do the each and every question, and If you have any doubts, ask me or mail me, but don't pending, complete each and every problem. Thank you.